So in this video we will see what is stationary wave and how stationary waves are formed on a string. So consider this orange color string which is tied to the wall. The one end of the string is tied to the wall. So now what happens is that when we move this string up and down continuously, we get a wave. Suppose we move this string upwards. So when we move this string in upward direction, one wave is formed, which is the pink color wave, which hits the wall and then it travels in the opposite direction with opposite phase. So the opposite wave which is traveling is shown in the lavender color. So if we continuously move the string up and down, what we get is the continuous wave which is flowing in one direction is reflected in the opposite direction. So the combination of the wave which is traveling towards the wall and the another wave which is traveling away from the wall gives rise to the stationary wave. So these two loops which we can see over here form a one stationary wave. So starting from this point to another point, one stationary wave is formed and the wavelength of this stationary wave is given by lambda. Over here you can see that I have written A and N. So this A signifies antinode and N signifies node. So node is a point on the string where the displacement of the point is minimum. So over here you can see the displacement of this point is minimum and displacement of this point is maximum. So where the displacement of the point of the string is maximum, it gives rise to the antinode, and where the point deflection is minimum, it gives rise to the node. In short, you can also assume that node is formed because of the distorted interference. Over you can see the trough of one wave and the crest of another wave are coinciding with each other, which gives rise to the distortive interference, and here the displacement of this particle is minimum, so it is known as the node. And over here this particle of the string moves to a maximum height, which is the antinode. So node is caused due to the less displacement and antinode is caused due to the maximum displacement. And after every half wave, that is lambda by 2, we get a node, or after every half wave lambda by 2 we get a antinode. So now let's see how these antinodes and nodes can be written in a mathematical manner. So we know that the wave equation can be represented as a sine 2 pi nt minus x upon lambda. This equation we have already done in the stationary waves video. You can go to the playlist and in the wave motion chapter you can search the stationary waves, you will find this video. So since this is moving, this is the equation for the pink wave. Because it is moving in the positive x direction, we consider negative over here. Now the lavender one, which is moving in the opposite direction, therefore we have to consider a positive sign over here because it is moving in the negative x axis. So y2, which is the lavender wave, is written by a sine 2 pi nt plus x upon lambda. Since stationary wave is the combination of both this wave, we simply add this wave. So this is the stationary wave y1 plus y2, which can be written as a sine 2 pi nt minus x upon lambda plus a sine 2 pi nt plus x upon lambda. So let's take a common over here. So what we get is, taking a common, so simply from here we have taken a common and we have written the same equation over here. So now in these curly brackets you can see one mathematical formula, that is sin C plus sin D. So If I don't know the formula, I am writing it over here. Sin C plus sin D is nothing but 2 sin C plus D upon 2 into cos C minus D upon 2. So this is the formula which we use in this equation. So now what we get after adding the sine terms is y is equals to nothing but 2a sine 2 pi nt into cos 2 pi x upon lambda. So this is what we get. Now further simplifying, we get y is nothing but equals to 2a cos 2 pi x upon lambda into sine 2 pi nt. Here what I have done is that I have simply taken 2a and cos term together. That's it. So now let's replace this whole term by a, capital A. Sorry. Ys is nothing but equals to a sine 2 pi nt. Just substitute this whole term with a. What we get is a into sine 2 pi nt, where this wave is nothing but the amplitude of the stationary wave. So this is the amplitude of the stationary wave. This whole term is the amplitude of the stationary wave. And now further on simplifying, what we get is that we know the formula for the omega is nothing but 2 pi n. Substituting 2 pi n by omega, what we get is a into sine omega t. So this is the formula, that is the mathematical representation of a stationary wave. So again revising, what we have seen is that if we move the string up and down continuously, we get two waves formed, one which is moving towards the wall and another which is moving away from the wall. The maximum displacement of the point from the mean position gives rise to antinode, and the minimum displacement gives rise to node. So every antinode is formed at a distance of lambda by 2, and every node is formed at a distance of lambda by 2, and the whole wavelength of the stationary wave consists of two loops, that is starting from this point to this point is the formation of one stationary wave. So simply adding these two waves, that is a pink wave and a lavender wave, we conclude with this equation, y is equals to a sine omega t. Guys, thanks for watching the video. If you haven't yet subscribed to the channel, please do it as soon as possible, because in the playlist you will be finding all the videos of 11th and 12th physics and chemistry as well as engineering. Thank you guys.